So number 1, 2, and 3 is getting and identifying patterns. And that was the first thing we learned. So I have 451, 431, 411, 391. What would be the next number? 371. So that's using inductive reasoning because you're using a pattern to make a general conjecture. What about here? 1, negative 10, 100, negative 100. 1,000? Looks like you're multiplying by negative 10, 7, 11, 18, 29, 47. What's going on? 76. What's the pattern? Is it adding? So plus 4, plus 7. Plus what? 11. What's going? Plus 4, plus 7. So that'd be plus. Oh, so it's not. Okay, so 7 plus 11 is 18. 11 plus 18 is 29. Good. So I induced that 29 plus 47 would be my next number here. So that's 76. Now, I didn't even ask you to explain the pattern. Just come up with the next number. Target rating. You guys have breakfast to throw away? Don't even throw it away. Target rating, I want you to go and identify what level are you at completing and identifying patterns. So rate yourself for the final time. Now use this as a study guide. If you're rating yourself a 1 or a 2, then you probably should study that this weekend for sure. You rated yourself? Is creating conjectures, which you could say this is applying inductive and deductive reasoning. So there's a guy named John, and we're supposed to create a conjecture from the information. So John likes to eat pepperoni pizza for breakfast. Interesting. He will usually have sausage pizza for lunch. Every night he will have a supreme pizza for dinner. What can we say about John? What do you think, Evelyn? John is unhealthy, eating pizza constantly. I suppose that works. Yeah, he more than likely is. Those probably aren't the most healthiest choice to make, right? That's very specific. And I didn't say to go inductive. Anyone have any others? What'd you get? Huh? John loves pizza. John is obsessed with pizza. John can only afford pizza. John is in college. John is a bachelor. There's a lot of conjectures that could possibly go there. There's a lot of questions about dating, I noticed. Josh and Mary met at dinner for their date. Josh kept telling jokes as Mary could not stop laughing. Josh's smile kept Mary's eyes on. Josh took Mary dancing after dinner. Their date lasted a total of 4 hours. It's a long date. What do you think? What would you say? How is Josh and Mary's date going? Josh and Mary are what? Josh and Mary will have a second date. Okay, that could work. They have what? Good time. That could work. Josh and Mary like each other. I hope you understand that me putting a response down does not mean you cross yours off, okay? So, Josh and Mary will get married tomorrow. Josh and Mary like each other. I'm going to go ahead and skip to number 9 because it goes with the next standard. So this is still going along with applying inductive and deductive reasoning. So number 9, we're supposed to label each as inductive or deductive. And remember, inductive is going from to a more general response. And deductive is general to more specific. I need to put something underneath this. So, Corey talks a lot when Mr. Blue tries to teach. That is one of the things I do not care for. Corey is told to be quiet constantly during mirth. Corey talks while he is supposed to be working on homework. So assume all of those are true, even if the teacher is not being correct himself. Okay, assume that all of those are true about Corey. So that's what Corey, that's his behaviors. Conjecture. I think Corey is going to get in trouble for talking too much someday. Would you say that's inductive or deductive? Inductive, because we're talking about 3 specific cases that lead to a more general action. So I would say this is inductive. And it does not specify to say why, but we are talking about why right now. Okay, Lexi is shy. Let's assume that's true. Even if we know secretly Lexi really isn't shy. Okay? Conjecture. I don't think Lexi likes to talk in front of large groups of people. So are we going, is saying she's shy to saying large groups, do you think that's inductive or deductive? Deductive? Are we going to something bigger or smaller? What do you think, Christina? Inductive? So you think you're going to something bigger? Let me think about this one. I could see an argument both ways, but let's say I'm shy. And then I am shy. So I don't like talking in front of other people. That would be something specific probably to a shy person. So maybe I'm thinking probably going from general to more specific. This is like saying Corey will get in trouble because he talks during work, because he does this. So I am going to actually say that this is deductive. However, I would probably, because of the English language issue there, I would probably take both. Okay. Sam studies very hard to get good grades. Sam also trains very hard after school for his football team. Sam doesn't skip class or practice. Sam sounds like an awesome kid. Sam is determined to accomplish his goals. Inductive or deductive? Yeah. Inductive, we're going from specific behaviors to a goal that's more brighter. I would say inductive. Brett is a huge baseball fan. So am I, in case you didn't know. Okay? So, he's a huge football fan, or baseball fan. I am positive that Brett has seasoned oils. So, being a baseball fan and having seasons, which one's under the other? If you're a baseball fan, things that show you're a baseball fan is you watch TV probably. You might have season tickets. You maybe watch other teams. Maybe you play fantasy baseball, right? So I would call that those are more specifics. So him having season tickets, I would say, is more deductive. And that one too, I could see the test will be a little more defined. Okay? So how do you feel about applying inductive and deductive reasoning? Can you tell me the difference? And can you make conjectures? When you get to college, you'll have conjectures that are mathematical statements, and the teacher will say, prove it. And so you start with what you're given, and you work down to what you're supposed to prove, and each line is a step in that direction. It's very... So applying inductive and deductive reasoning. And if you need to copy this down, I can let you copy it down here in a minute. But you should have rated yourself right here. Either 1, 2, 3, or 4, your choice. So, as a second ago, I said, if you don't do this, I will let you copy it afterward. Okay. Next, can you look at arguments and identify them strong and weak? And if it's weak, can you provide a counterexample? So that would be questions 6, 7, and 8. Okay, so we are going to assume that these are true. 2 plus negative 5 is negative 3. That's true. 5 plus negative 101 is negative 96. That is true. Negative 1,000 plus negative 1,001 is negative 1. So my conjecture based off these 3 examples is a positive number plus a negative number is always a negative number. So a positive plus a negative is always negative. A positive plus a negative is always negative. A positive plus a negative is always negative because I showed you 3 examples where that's true, therefore it must be true. Strong or weak? Weak. You guys learned in middle school that when you add a positive and a negative, the sign you take is from whichever number of the absolute value is larger. Correct? So we know that that is completely false. So what is an example that would make that? Say what? So a positive number, 15, plus, what's your negative number? Huh? 5? No, it has to be a negative number. Negative 5 is always a negative number. Well, 15 is positive plus negative 5, which is negative, and 15 plus negative 5 is 10, which is not negative. So that is my counterexample. In fact, there are a lot of, it's not just 15 plus negative 5, there's many of them. Next, negative 2 times 3 is negative 6, negative 5 times 6 is negative 30, negative 3 times 4 is negative 12. So, based off those 3 examples, I say a negative number multiplied by a positive number is always a negative number. Is that strong or weak? Strong. That's a mathematical property, that if you take a negative number times a positive number, it will always be negative. There are no counterexamples. And you could say 0, but 0 is neither positive or negative, right? Miss is a teacher and doesn't play video games. Mr. Nation is a teacher and doesn't play video games. Miss Barnes is an administrator and doesn't play video games. So I say that none of the Wyandotte staff plays video games. Weak? And it's probably weak because you can't just make a general assumption about 3 people. Now this is where, I don't know what your relationship's like with your teachers, but you may not know this answer, like math teacher. And if that happens on the test, just say weak. Surely my counterexample is surely there's at least one, does it have to be math? No. Surely there's at least one teacher at Wyandotte that likes to play video games out of 100 teachers, right? And I can name a few. I know Mr. Bruss is a big video game person. Pretty sure Mr. Parker is a big video game person. I'm not. Okay, so I wouldn't work. But let's put down Mr. Bruss. I know he even had a video game club for a while. That is an unfair question if you don't know your teacher. So just put, if you don't know a specific person, just kind of give the general. So how do you feel about identifying strong and weak? And if weak, providing a counterexample. Rate yourself. 1 means you have no idea. 2 means you need help. Not one person stayed after school yet. 3, you understand. And 4, you understand and you can tutor. So you're rating yourself. I know a couple of you need to copy this page. I'll let you do that here in a little bit. For now, just rate yourself. And if you are filling out this whole paper today, this is something we do as we go along. So you probably won't get your points for this. Next is, can you identify, and on the homework, some of you forgot to identify your problem solving strategy. So can you identify the problem solving strategy and can you use it? And that would correlate to question number 13. So we have 6 tennis players who are competing to win a trophy. Each of them will play each other in singles tennis match. You guys know what that means? 1 versus 1. Okay. No one will play the same person more than once. How many total matches will be played? What is the problem asking? So we have 6 tennis players. Each of them will play each other in singles. And then no one will play the same player more than once. How many total matches? I would say the problem, I don't get that question because, you can't really make it any more specific, but how many total matches will be played? So how many times will they play each other, right, in tennis? Maybe you say that. And I'm going to use the strategy, and there's, if you know your probability, you can get this too. I'm going to make a list. I am going to make my list, so I don't have to list out players. I'm going to list my players as player A, B, C, E, and F. So making a list, A is going to play B, right? A is going to play C. A is going to play D. A is going to play E. A is going to play F. Correct? Because it says each of them will play each other. A has now played everyone. We're good. Now, go to B. I'll even use a different color. B already played A. So we're not going to have them play again because they only play each other once. But B has not played C. B needs to play with D. B needs to play with D. And B needs to play with F.